So let us see one more problem. A can do a piece of work in 4 hours. B and C can do a piece of work in 3 hours, while A and C together can do it in 2 hours. How long will B alone take to do it? So you can use the same method. Here you are having 4, 3 and 2. You need to take the LCM of 4, 3 and 2, the LCM of 4 and 3. See, LCM of co-primes, always LCM of numbers which are beside to each other, simply you can multiply them. 4 3 is 12. So 12 is also LCM 12. 2 is a factor of 12. Directly you can take 12 units. So 12 units is the total work. Whatever it is, 12 units is the total work. Here it is given A can do the work in 4 hours. So if it is 4 hours, and next we will see B plus C can do it in 3 hours, and while A plus C can do it in 2 hours. This is the data given. So here we need to find the time taken by B to complete the work. So we will now let us find the capacities. So the capacity of A is this is 12 units. 12 by 4 is 3 units per hour. Okay. So per day, here we are having hours, that is why I am taking hours. See, this is 12 by 3, the capacity is 4 units per hour, and this is 12 by 2, this is 6 units per hour. So we got all the capacities. So we got the capacity of A directly. Capacity of A is 3 units. So we can substitute A here. A is 3 units and their combined capacity is 6. So this is 3 and C's capacity must be 3. So 3 plus 3 gives you 6. So if C's capacity is 3, then B's capacity must be, here you can see, so B plus C is 4, so B's capacity must be 1. So here you need to find capacity time taken by B alone. So we got B's capacity. B can complete 1 unit work per hour. So what is the total units? 12 units. So time taken by B. So time taken by B. So this can be written as 12 units by 1 unit per hour, and cut directly it will get 12 hours. We will see one more problem. So this is a new problem. See, P can complete a work in 12 days, working 8 hours a day. So okay, now Q can complete the same work in 8 days, working 10 hours a day. If both P and Q work together, working 8 hours a day, in how many days can they complete the work? So when you have a question like this, see, this is the hours per day is not constant. Here it is 10 hours per day, here it is 8 hours per day. So directly, so P can complete the work in how many hours? 12 days and 8 hours. So 12 8s are, so 12 8s is 96. So P can complete the work in 96 hours, whereas Q can complete the work in 8 10s 80 hours. So now the same, we can proceed with the same arrangement. So we can take LCM of 96 and 80. So 96 and 80, if we take it 96 80, so both are divisible by 8. So 8 1s 8, 8 2 16, 8 12 96, then 8 10s. So both of them are divisible by 2, 2 6, 2 5s. So they do not have any common factor between them. So 6 5s 30, 32 60, 68s 480. So the total unit is the total work is 480 units. So P can do it in 96 hours. That means, and here it is given Q's capacity also. Sorry, Q's time taken. So it is 8 into 10. It is 80 hours. So you can find the capacities. Capacity of P is 480 by 96. So 96 5s is 480. So it is 5 units per hour, and here it is 8 6 are 48. So it is 6 units per hour. So you have the capacity of P as well as capacity of Q. So they are working together. If they work together, the capacity of P and Q. If they work together, the capacity of P and so it is P plus Q. 5 plus 6, it is 11 units per hour. So 11 units per hour. So total is 480 units. So total hours needed. Total hours. We are calculating it in hours. Total hours, it is 480 by 11. So 480 by 11 hours. Sorry, 480 by 11 hours they need. So but they are working 8 hours a day. So together they are working 8 hours a day. That is now we will take total days needed. So if we need to take total days needed, per day they are working 8 hours. So we need to divide 480 by 8 into 11. So if we divide that 8 ones, 8 6. So 60 by 11 days. They need 60 by 11 days. So 60 by 11, if it is written in the mixed fraction, so 11 5s are 55 and 5 is left over. 5 by 11, 5 by 11 days. So this is 11 5s are 55 plus 5, 60 by 11. So they together they can complete the work in 5 by 11 days if they are work 8 hours a day. This is the problem. Next problem. See, A can do a certain work in the same time in which B and C together can do it. So it is given A can do a certain work in the same time in which B and C can together do. And if A and B together could do it in 10 days and C alone in 50 days, then B alone could do it in. So here also we will take the LCM of these two, 10 and 50. If we take the LCM of 10 and 50, it is 50 because 10 is a factor of 50. So directly LCM is 50, and here can take A plus B. It is given 10 days. So their capacity is 5 units per day, and C's capacity is 50 days, and so C's time is 50 days, and its capacity is 1 unit per day. So now we can write A plus B plus C. What is the total capacity of A plus B plus C? See, here we have A plus B's capacity as 5 units per day and C's capacity as 1 unit per day. But we need only B's capacity. Then B alone could do it, only B's capacity. So from this we can write A plus B plus C's capacity. This is 5 plus 1. This is 5 plus 1 because A plus B is 5 and plus 1, it is 6 units per day. But it is given A can do certain work in the same time as B and C together. That is, capacity of A is equal to capacity of B plus C. So this B plus C can be replaced with A. So this is A plus A, and it can be written as 2A is equal to 6. So A is equal to 3 units per day. You got the value of A. So A is 3. If A is 3, A plus B is 5. So B must be 2. So you got the capacity of 2, capacity of B. So capacity of B is 2 units per day. So time taken by B, number of days taken by B, it can be written as, so total work is 50 and B's capacity is 2. So this is 25 units per day. This is how we can solve the problem very easily and very quickly using this technique. Next problem. Here it is given A is thrice as good workman as B and therefore is able to finish the job in 60 days less than B. So here it is A is thrice as good workman as B. That is, efficiency of A or capacity of A is 3 times that of B. That is given, and is able to finish a job in 60 days less than B. Here capacities of A and B are in the ratio, just I am writing A by B are in the ratio 3 by 1. So here in the previous problems also we have seen, if the capacity is more, that means the work will be done in less time. If the capacity is less, the work is done in more time. So capacity is always inversely proportional to time. Here the capacity or efficiency, what we see, this is inversely proportional to time taken. So here A by B, the capacities are in the ratio 3:1, 3 by 1. Okay. If we take time taken by A, we take time. So time taken by A, so time taken by A and B are in the ratio 1 by 3. This becomes just an inverse by B. So this is time taken. Okay. So this can be written as x and 3x. So time taken by B is 3x, time taken by A can be taken as x. So here we are having a difference that A is able to finish the work 60 days less than B. That means B will do 3x days, A will do x days. So 3x minus x is equal to 60 days. That is given. So x is equal to, 2x is equal to 30 days. X is equal to 30 days. So here A can complete the work in 30 days and B can complete the work in 3 into 30. So 90 days. So here we can use any formula. Or we can use the method which we are using. So LCM of 30 and 90 is 90. We know A can complete it in A's efficiency is 3, B's efficiency is 1, we know it. Or A, if we take 30, so 90 by 30 is 3, 90 by 90 is 1. So if they do together, they do 4 units per day. Their efficiency is 4, 3 plus 1. So time taken by them is 90 by 4. So we will get around 22 and a half days. 45 by 2, it is 22 and a half days. Here is a new problem. A can finish a work in 18 days and B can do the same work in 15 days. B worked for 10 days and left the job. In how many days A alone can finish the remaining work? So here we are having 18 days and B can complete it in 15 days. So we can take LCM of 18 and 15. So if you take 18 and 15, they are the multiples of 3. That is 3 6 are 18, 3 5s are 15. So LCM of 5 and 6 is 30. So 30 into, we have taken 3 common, 30 into 3 it is 90. So LCM is 90. So A, it is 18 days. So A's efficiency is 18 5 units per day. You can take. So B, it is 15 days. So 15 6 are 90, 6 units per day. Okay. And it is given B worked for 10 days. So B worked for 10 days. Here the B's capacity is 6 units per day. So in 10 days he can complete, in 10 days, so B can complete 10 into 6. That is, he completed 60 units of work is already completed. Now the remaining work is total work is 90 units. Okay. This is total work. Always the total work is taken as LCM. So remaining work is 90 minus the 60 units of work is completed by B. So in 10 days, so we will subtract that 60, so we will get remaining as 30 units. So remaining is 30 units. So 30 units A has to do alone. So the days taken by A. So directly can write days taken by A, because we know A's efficiency. A's efficiency is 5 units per day. We can days taken by A, we can write it as 30 by 5. So we can write it as in 6 days he can complete the work. This is how we can solve the problem. We will directly arrive at the solution in an easier manner. So let us see the next problem. See, A can finish a work in 24 days, B in 9 days, and C in 12 days. Okay. B and C start the work but are forced to leave after 3 days. The remaining work was done by A in how many days? We need to calculate. So here we are having directly days 24, 9, 12. Directly we need to take LCM of 24, 9, 12. So, but here we know this 12 is a factor of 24. We need not take LCM of, we did not include 12. Directly we can take LCM of these two numbers, 24 and 9. So 24 and 9, these are multiples of 3, 3 8s and 3 3s. Okay. So now directly we can go 8 and 3 are not having any number, any factor in common. So 8 into 3 into 3. So 3 into 3 is 9, 8 9 is 72. So 72 is the LCM. So we can say total work is having 72 units. And A can finish a work in 24 days. So that means 24 3 is 72. His efficiency is 3. B can finish a work in 9 days. So 9 8 72. B's efficiency is 8. Our capacity or efficiency both one at the same. So C can do it in 12 days. So his efficiency is 12 6 are 72. So these are the capacities. Capacities are efficiencies 3, 8, 6 of A, B and C respectively. Here B and C started the work but are forced to leave after 3 days. That means B and C worked for 3 days. So B and C, so B's efficiency is 8 units per day, C's efficiency is 6 units per day. So 8 plus 6 is, so B plus C worked for 3 days. So B plus C into 8, sorry, B plus C, they worked for 3 days into 3. So 8 plus 6 is 14, 14 into 3. So it is 42. So 42 units of the work is already completed in 3 days by B and C. So the remaining units of work, so the total work is 72 units and 42 units is completed. So remaining is 72 minus 42, it is 30. So 30 units of work has to be done by A. So the remaining work was done by A in how many days? So days needed for A, this is same, days needed for A. So the remaining work is 30. A has to do only 30 units of work because 40 units of work is already done by B and C. So 30 and his capacity is 3 units per day. So 30 by 3, we can complete it in 10 days. This is how we can solve this problem.